In this video we're looking at S1 Chapter 9 correlation. Now you'll have come across correlation at GCSE. Correlation is how you describe what you see on a scatter diagram. And on the scatter diagram, if your set of points is generally going uphill, then that's called positive correlation. If they're showing a downhill pattern, that would be called negative correlation. And if they were showing no sort of pattern at all, then that would be described as no correlation. So we have positive correlation, negative correlation, or no correlation. And it's always looking at, is there a straight line pattern there? But you may have positive correlation that was looking like that, and you may have positive correlation that's looking like that. Both of those are positive correlation, but they're clearly slightly different to each other. This one over here is very close to a straight line, so we may call that strong correlation, whereas over here this correlation is definitely a weaker correlation than the one over here. They're not so close to a straight line pattern, there's more variability in it. And what correlation in A-level does is puts a number on the strength of the correlation and the type of correlation. So here, while these are both positive, rather than use the word stronger or weaker, we'll put a numerical value on it. So correlation measures the strength of the association between two variables, identifies whether it's positive or negative, and there are three important values, numerical values for correlation. A correlation of 0 means there is no correlation at all. A correlation of 1 means there would be perfect positive correlation. That would mean all the points were actually dead on a straight line and it was going uphill. A value of -1 would be perfect negative correlation. It would be a perfect straight line going downhill, and then everything else is somewhere in between those two extremes. So for example, it may have been this one here, which is positive and quite strong. That might have been a sort of a plus 0.8. It may have been that this one here was a minus 0.75. That one over there, a value very close to 0. So to put a number on it, we need to do some calculations. Now there are two methods, two different sorts of calculations you need to know for A-level. The first method is what's called the product moment correlation coefficient. The product moment correlation coefficient. And sometimes that's just known as the PMCC. For fairly obvious reasons, we don't write that down too often. And it has a formula, and you haven't got to worry about where it comes from. And it looks, to start with, quite a strange formula. The value is called R, and R is equal to S with a little xy over S with a little sx, S with a little yy, and the bottom part of that fraction is square rooted. You say, well, hang on, what are these things? Well, each of these has its own formula as well. Sxx is equal to the sum of the x values squared, take away the sum of the x values all squared over n, n being how many there are. Syy is exactly the same, but every x is a y. It's sigma y squared, take a y, sigma y, all squared over n. And the value on the top, the Sxy, that is sigma xy minus sigma x times by sigma y over n. There is a pattern here, because if this one here, the sigma y squared, you could think of that as sigma yy, whereas the xy one is xy and the xx one is xx. And then over here, That is sigma x times sigma x. That's sigma y times sigma y. This is sigma x times sigma y. So there is a pattern here in these three formulae. So if you have a set of data, maybe a set of paired data, maybe you have x and y values that look like this, you have to work out various different things. If you look at the formula a minute, you need an x squared column in your data table, you need a y squared column in your data table, and you need an xy column, an x times by y column in your data table. So if you have a set of data like this in a table and you've got to work out the product moment correlation coefficient, you need an x squared column. You can either label it x squared or you could label it xx. You need a y squared column. You could work those out, either label it y squared or yy. And you need an x squared column, an xy column, which is your x value times your y value. They're all easy to work out, but it will take a lot of time to work out. And we'll talk about that in a minute. And when you have worked out each of those columns, what you then need is the total for each of them. So down here, this 89 will be sigma x. This value here will be sigma y. This value will be sigma x squared. This will be sigma y squared. And this value will be sigma xy. And now what you have is all the values you need to go in here. You can work out first of all sigma sxx. So if I try and put both things on there at once, in this example, sigma sx will be the total of the x squared column, which is this 1061, take away the total of the x column, which is 89, squared, divided by however many pairs of numbers we had. And in the example here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs of numbers. The SYY would be the total of the y squared column, take away the total of the y column squared divided by 10. And then the final one, the SXY, is the total of the xy column, take away the total of the x column times by the total of the y column divided here by 10, because there are 10 pairs of numbers. What you would do in the exam if you were doing this is work out each of these things. It's done here for you. You can see the value of SXX, the value of SYY, the value of SXY. You then substitute those three values into your formula that gives you the value of R itself. And if you did that here in this example, it comes out to be 0.678. 0.678 is a reasonable positive correlation. It's beyond the scope of your syllabus for S1 to really say how significant it is. If you had two correlations, you could easily compare them and say which one was the stronger one. If you went on and looked at further statistics in a different unit, or maybe for a different syllabus, you can actually have other tables which tell you basically for a sample of size 10 whether that is strong or whether that is weak, that sort of thing. So what I suggest you do now is have a go yourself, maybe pause the video in a minute, and if I just cover up everything apart from the X and the Y data and the column headings up here, work out for each of those rows the X squared value, the Y squared value, the XY value, and then work out the value of SXX, SYY, SXY, and then the value of R. So if you want to pause it in a minute, you can do. You can have those numbers in front of you, and I'll take everything away after that, and then you can see everything as well. There you can see now the totals, the values of each of the three parts of the formula, and the overall value you have there as well.